Assalamualaikum and hi, my name is Farid. I'm a final year student. So today I would like to present my final year project too. So the topic is about mechanical properties of recycled polymers reinforcement with glass fiber composite material. So this is an overview of my slide. It's about the introduction, literature review methodology, result and discussion, conclusion and recommendation. So for the firstly, introduction. So the first point, as we know, the higher performance and durability of composite fiber development in this recent year has remarkably strong. So secondly, recycling is now as the most environmentally sustainable mechanism for the disposal of plastic. So this is an overview of the characteristic of glass fiber and their composite in terms of computational modeling of composite. This study was conducted to understand the effect of reprocessing on the glass fiber and polymer mechanical properties. So for the problem statement in this experiment, is the aim of this project is to provide a true assessment of carbon fibers and the glass fiber recycling. So the concept of the recycling are highlighted in terms of manufacturing waste of the product and being remanufactured carbon fiber reinforced polymer. Most important point is the percentage ratio between the polymer and the glass fiber is one of the main important elements for this experiment. And last point is the reinforcement of polymer and glass fiber is high due to different mechanical properties. So for this experiment, the first objective is to review or to study the mechanical properties of reinforced between the carbon polymer or the mixing using tensile and flexural test. So for the second objective is to study the sustainable percentage ratio of reinforcement between glass fiber and polymer. So this is some of the literature review. As you know, you can read at the table the number of the journal, the description and the year of the journal. Going through for the description, thermosetting polymers form a molecular arrangement. PET is polyethylene, a hard, stiff, strong, stable material. PP is polypropylene properties, distortion, clarified, and dimensional stability. The mechanical properties of polypropylene. So CFRP is carbon fiber reinforced polymer, have a high specific strength, rigidity, and lightweight. Carbon fiber will improve the performance. So eco-friendly of recycled CFRP method. Recycled carbon fiber has less than 10%. GFRP is a material is made out of glass fiber. GFRP is glass fiber reinforced polymer. So relatively high mechanical qualities. GFRP gives strength structural material. The tensile and flexural strength, the additional of carbon fiber. Flexural is defined strength as the maximum stress. So this is for the methodology. Firstly, when we start, we raw material selection between polymer like PP and PET, and for the mixing is the carbon fiber or the glass fiber. We crunch the raw material for the polymer using plastic granulator. Next, we mix this product for the glass fiber and the polymer, into a Brabender Plastograph machine. Next, we inject this mixture into a injection molding to form a new specimen following by the standard. And we test it with mechanical testing, flexural and tensile test. This test followed by their standard. And lastly, we analyze this specimen will be analyzed by data and result. Discussion, graph and data experiment is formed. And that's in the finish. This experiment has been started. As we know, for the MCO for our country, this experiment will stop. I've run this experiment for 50%. This is the machine that I have been used, and for the study about the formula for mixing. So 50% of the experiment is I'm doing until this machine, and all the mixing have been completed. And next step is for doing the injection molding, but MCO. So I've stopped recently my experiment. So we study a little bit about the formula of mixing. So for the formula is M equal to V times Fc times K. So for the M is the sample weight. Next for the V is mixer chamber volume, is around 55 cm3 that has been given. So FC is composite density, G per cm3 density of the product or the mixing for the main mixing. So lastly for the K is constant that has been given. Example is 0.7 or 0.8. For distillation is 0.7. So example for the calculation. So for example, using the polypropylene and glass fiber, this is the most suitable material. So if the density of polypropylene is 0.92, you calculate using the formula 55 cm3 times 0.92 times 0.7. The given is 35.42 gram of a sample weight is needed for one-time mixing. So for the one-time mixing, we need 35.4 gram. So if we need the percentage of glass fiber is around 3%, so we need times 0.03 around 2 gram, and the polypropylene around 33 gram. So we mix it. So for the first time mixing, and we need to repeat it manually. So for the suitable for injection molding, we need around 200 gram for one specimen. So we need to doing around 5 to 6 times to get 200 gram. For doing next step is injection molding. So for the first each time for the mixing, we need around 7 to 10 minutes. So this machine is very difficult to handle, especially for the clean up. So next we go into the result and discussion. As we know, the table is description for the number of journal, year, percentage, weightage, and fiber and the finding. So for the carbon fiber for the first journal and ABS is the nature of the material. So composite containing 10 times continuous carbon fiber had a tensile strength of 147 MPa. Fiber reinforcing of 5 to 10% in FDM polymers improve tensile strength and modulus. So for next, the banana and yam fiber. As a result, banana or yarn is the strongest. When compared to banana yarn, configuration proved to be the most effective. This due to the yarn fibers in the composite being continuous and commonly by their configuration. So for the next, glass fiber, the experimental result high strength glass fiber, play a role skeleton reinforcement with tensile strength nearly increasing as glass fiber content increase. For the glass fiber, carbon fiber and aramid fiber, the maximum nominal stress tend to decrease as the fiber concentration rise. At the beginning of the load, the slope tended to rise, then this pattern will evident and analyzed in all times. So next for the glass fiber, the findings show the largest fiber content plastic. Deformation occurs at a greater stress level and the composite has a higher yield strength. This finding show as a fiber increase, the composite resistance to elastic deformation improve. For the last journal, glass fiber, the addition of 50 weightage% glass fiber to composite increases their stiffness by 6 times. The reinforcement also help to improve the composite tensile strength. Blending 50% of TLCP into the composite increase the tensile strength by 114%. The addition of 50% long glass fiber to polypropylene increased the tensile strength of the composite by more than 3 times. In conclusion, due to the study effect of fiber give different mechanical properties of characteristics. Due to the research, the percentage of glass fiber for the first suitable is under 10% of glass fiber, and the other percentage is the remaining percentage for the polymer. For the range percentage, around 3, 5, and 7% of glass fiber is the most suitable for this experiment. And lastly, for the tensile test, range between 3% to 12% of glass fiber give the increasing of tensile strength to 43.4%. Flexural test range percentage from 2% to 10% give increasing in flexural in from 43 to 47%. It's quite high. So for the recommendation for this experiment, we must find or using a suitable of type of fiber or the glass fiber in the enforcement to get a better performance in mechanical properties. Next is the most important point is we must find or suitable percentage of glass fiber with the mixing machine Brabender Plastograph to prevent from gross machine. As we know, this machine is very hard to handle or difficult, especially for the clean up time. So we must find the suitable polymer and the fiber. The polypropylene is the most suitable because they are low melting point compared to the PET where the higher melting point, and the polypropylene is not as hard as a PET. So lastly is to find the suitable characteristic of polymer to make easier when clean up the mixing and injection molding. As I said that PET is very hard, stiff and strong, and PET is not as hard as the PET, so PET is the most suitable polymer to use it because it is easier for us to clean it up. I think that's all for my project. I hope this project will be continuous by the future student, and because my experiment is cannot be continued due to the MCO, I also just doing this experiment for some research and a review paper. I think that's all for me. Thank you very much.